Today we are approximating square roots, and there is more than one way to do this. So this is called Approximating Square Roots Part 1, and we're going to be using long division to do this. The less objective, the standard that goes along with the less objective is this right here, which you can look up and see the whole standard. We've got it posted in our classroom right now. But it says for the I can statement, the part that's important for you to feel like you can do by the end of the lesson is I can give decimal estimations of irrational numbers. So we got this problem that we talked about already in class, but we've got a little bit of a different extension to it here at the bottom that we'll get to. But the problem says Mr. Malcolm has enough 1 foot by 1 foot carpet tiles left over from a building project to cover an area of 38 square feet. So he's got 38 of these carpet tiles. He's offered to donate the tiles to a neighborhood preschool. The preschool wants to make a carpet a square reading area with the tiles. What is the largest square from these tiles they can make? So to help us out, we're going to list the perfect squares in order up to 225. And we've done this a couple times already in class. But I want you to go ahead and do this. It's going to help you continue to get these memorized. So pause the video right now for a minute, and I want you to fill this in right here and list all the square roots and their perfect squares. All right, I'm assuming you have completed that. I'm going to go ahead and fill this in. You just check to see if you've got this correct now. So I'm going to list all the square roots first up here. And that's going to help me be able to list out the perfect squares that go along with them. So for example, 1 squared, or 1 times 1 is 1. 2 squared, 2 times 2 is 4. So 1 and 4 are your first perfect squares. 3 times 3 is 9, it's the next perfect square. 4 times 4 is 16. 5 times 5 is 25. 6 squared is 36, and we're just going to keep going. 49, 64, 81, 100, 121, 144, 169, 196, and 225. So those are all the perfect squares down here along the bottom. If you had exactly that many square tiles, you could make perfect squares from these numbers. Every other number would not make a perfect square. You could make a rectangle or a square with some left over, but you can't make a perfect square unless you have exactly these amounts down here along the bottom. So it says, now imagine Mr. Malcolm offers to cut up some of the tiles to use all 38 and still make a square. About how long will each side be? Round your answer to the nearest tenth. So they're going to make a perfect square with the ones that they can do a perfect square with, and there's going to be some left over, and they're going to cut those up and line them up along the outsides of the square to make an even bigger square, but it won't be whole numbers anymore, it won't be whole squares anymore. So we're going to go through a step-by-step process today to help us estimate the square root of 38, because if you know the area of something, you take the square root to find the length of one side. We've talked about that in class. So we're going to go through this process now by taking the square root of 38. So it's a 6-step process. We're going to use long division today to estimate this. So first thing is to write the two perfect squares on either side of 38 and write their square roots. So go ahead and write 38 down. The perfect squares are these numbers along the bottom here, not the ones up above. So on either side of 36, so the one that is less than either side of 38. So one that's less than 38 is 36. And the one that's more than 38, if we go from 36, the next one up is 49. So 49 will go here on the other side of it. So this is going to go in between its two perfect squares on either side. And it says, and write their square roots. So go ahead and show that you're going to take the square root of 36 and the square root of 49. The square root of 36 is 6. The square root of 49 is 7. So you're going to list the two perfect squares and write what their square roots are. Let's copy what we've done so far here. 38 is what we're going to estimate here in a minute. The two perfect squares on either side are 36 and 49. The square root would be each of these. Square root of 36 is 6. And the square root of 49 is 7. There we go. So the whole number of our answer, the whole number of our estimate here, is the square root of the smaller perfect square. So in other words, if we take the square root of 38, it's going to be between 6 and 7. So anything that's between 6 and 7 is going to be 6 point something. So we know that it's going to be the whole number of the square root of the smaller perfect square. So it's going to be 6 point something. We don't know what the point something is yet. That's going to be what we're going to figure out here in a second. So this part's just determining what the whole number is. It's always the square root of the smaller perfect square. So let's copy down what we've done so far here. We're trying to find an estimate for the square root of 38. Write the two perfect squares on either side, 36 and 49. Write their square roots, 6 and 7. So we know the square root of 38 will be between 6 and 7, 6 point something. So let's read the next step here. It says, determine how far 38 is from the smaller perfect square. In other words, we're in between 36 and 49, but how far are we in our number we're taking the square root of from the smaller perfect square? That's going to be the numerator here in our fraction. So we're going to write a decimal here in a minute, but for now we're going to write a fraction, and then we're going to change that fraction to a decimal with long division. So from 36 to 38 we go up just 2, so that's our numerator in our fraction. So this is the distance we find to find our numerator, from the smaller perfect square to the one we're finding finding this estimate of, the square root of 38 in this case. Okay, so let's copy what we've done so far underneath step number 4. We're trying to find the square root of 38. So we write the two perfect squares on either side, 36 and 49. And we write their square roots. Square root of 36 is 6, square root of 49 is 7. We're taking the square root of 36. We know it's going to be 6 something because it's between 6 and 7. And we just found our numerator was 2 because it's the distance between a smaller perfect square and the one we're taking the square root of in the problem here. Now, the next part is to find our denominator. It's to determine how far apart your two perfect squares are. So the distance between the two perfect squares now, that's our denominator. So our first numerator was just between these two, between the smaller perfect square and the number we're taking the square root of, but this is the distance between the two perfect squares. So from 36 to 49, the difference there, you could just subtract them, 49 minus 36, you get that. It's 13. So this is our estimate, 6 to 2 over 13, but we're going to want to write it as a decimal. So let's go ahead and write what we've got so far here. Well, actually, you know what? In this since we're going to change this now, we've done all the way up to this part. So let's go ahead and just do our long division now. We won't have to write everything we've written so far. So we're going to take 6 and 2/13, and we're going to change this. We've already done long division this year, so I'm not going to do this step by step. We're going to do it all in this box here. We're going to take this fraction and we're going to write it as a decimal, and we're going to go to just 2 digits after the decimal. So the numerator goes on the inside, the denominator on the outside, but decimal point with some zeros after it here. Decimal point above that. Our whole number we already know is 6, and so we begin to divide here. 13 goes into 20 just once. 1 times 13 is 13. We subtract. 20 minus 13, we borrow from the 2 here. 10 minus 3 is 7, and 1 minus 1 is nothing. So you bring down a 0. And now we got to figure out how many 13s go into 70. And we may not know that right off the bat. So if you don't know, here's what you can do, because we're going to run into a lot of these today where we're maybe dividing things we're not used to dividing. So one thing you could do is just start listing your 13s. So 1 13 is 13. 2 13s, 13 plus 13 is 26. 3 13s is 39. 4 13s, this is where things get a little bit tricky here, but you could always just add 13 more here. It's 52. So we're trying to fit into 70, so we still got a little room left here, I think. 5 13s, add another 13 to that, we have 65. We're under 70. If we do another 13, 6 13s is 78, and we've gone over. So we never want to go over this number we're trying to fit into. So 13 into 70, our best fit is 5 of them. So put a 5 here. 5 times 13 is 65. And we only have 5 left over, so we know we're good to go there. There's not more than 13 left over. So we just need 2 numbers after the decimal. So let's go ahead and write what we've got here. We've got 6.15. But we're only going to round our answer to the nearest tenth. Now we need two numbers after the decimal to round to the nearest tenth, because we're going to look at this number now. If it is 5 or more, it moves this 1 up to a 2. If it's less than 5, then it just stays the same. So this is 5 or more, so it's going to round up to 6.2. So the answer is that if Mr. Malcolm were to cut up these leftover squares and add them on to make an even bigger square with some partial carpet pieces on the ends, each side would be about, this is an estimate, about 6.2 feet. So we're going to continue. We're going to do a few practice problems here. It says estimate each square root to the nearest tenth without a calculator. We're going to follow the same six-step process, but we're not going to have to write it out step by step. So number 1 is the square root of 22. The first thing we're going to do is go ahead and write 22. We're going to write the two perfect squares on either side of 22. Now I'd like you to be able to do this without looking at the chart up here, okay? But if you need to look at the chart for a while at least, that's okay. You should have these memorized, but at this point, if you don't, you can look up here to see. So 22 would fit between 16 and 25. So those are the two perfect squares we're going to write on either side, 16 and 25. Okay, we're going to take the square root of these two numbers now to see what the whole number is. If we take the square root of 22, that we're going to be between. So square root of 16 is 4, square root of 25 is 5. So that means we take the square root of 22, we're going to be somewhere between 4 and 5. So we know it would be 4 something. So remember, this smaller perfect, the square root of the perfect square here is always going to be your whole number. Now we got to write ourselves a fraction that we can change it to a decimal. The numerator is the distance between the smaller perfect square and the square root in the problem. So between 16 and 22, 22 minus 16, the difference is 6. The denominator is the distance between the two perfect squares from 16 to 25. So 25 minus 16 is 9. And this can actually be reduced. So if you can reduce it before you start dividing, that's even better. 6 and 9 can both be divided by 3. So we can write that as 4 2/3. And you may know what this is as a decimal, but we're going to go ahead and do our long division here just to make sure. So the numerator will go on the inside, denominator on the outside. We know our whole number is 4. 3 goes into 20 6 times. 6 times 3 is 18. 20 minus 18 is 2, bring down a 0, and 3 goes into 20 another 6 times. And we know that we don't have another 6 that'll fit in there because we're just left with 2 there. So 4.66, and we're going to determine if it's going to be 4.6 or under 4.7. Looks like the 6 is going to move that up to a 7, so 4.7 is our best estimate there. That makes sense because 22 is closer to 25 than to 16. So you take the square root of it, it's going to be closer to 5 than it is to 4. Let's do one more, and then we'll just do some more practice in class here. The square root of 42. So write your number you're taking the square root of. Write the two perfect squares on either side of 42. And again, if you need to look at your chart, you can, but try to come up with those. On the lower end, we have 36. On the upper end, we have 49. Okay, so we're going to go ahead and show we're taking the square root of all these. Square root of 36 is 6. Square root of 49 is 7. So we know this is going to be 6 something because it's between, we take the square root of, it's going to be between 6 and 7. The numerator will be the difference between 36 and 42. That's 6. The denominator will be the difference between 36 and 49. That's 13. So our fraction is 6 and 6 over 13. Let's change that fraction to a decimal using long division. So 6 on the inside, 13 on the outside. And our whole number is 6. 13 goes into 60. And we did this earlier here with our 13s. So we can look here and see how many would fit into 60. Looks like we're going to be stuck at 4 here, 52. And then 65 would go over. So 4 of these. 4 times 13 is 52. 60 minus 52 is 8. Bring down to 0. If you look up here again, if we're trying to fit 13 into 80, 6 13s is 78. So that's going to be our best way to get there without going over. 6 times 13 is 78. And we're just left with 2. So this is a good estimate. 6.46. This number here is 5 or greater, so it's big enough to move that 4 up to a 5. 6.5 is our estimate. Again, these are just estimates. We're not getting an exact answer here. We're just coming up with something that's close. We'll do some more practice with this in class, but hopefully this gives you a start on changing or getting estimates for square roots using long division.